No, we have I'm the chairman of this group, so we keep track of all the slaves we have. So that's dangerous. The discussion I just but is the law. Yeah, you want to go have a seat on the couch. So this is how we're able to keep track of everything.
We are live.
We're live? Okay.
Yeah, you can go ahead and get started, Bob. Thank you. First off, I just want to thank you, Cass, for offering to present this topic because it's not one I'm terribly familiar with, but it sounds intriguing. So.
Yeah. First of all, if anyone wants to follow along at home or on your laptop, there's these presentations publicly available. Slides.com/rtward/mesos. Then you can play the home version.
We're live. Sorry.
So who am I? My name is Robert Ward. I'm the founder and one of the founders and chief engineer at Juristat. I do ETL, data processing, and all of our DevOps stuff, which is why I'm here. My contact info at the bottom. I've been working with Mesos now for past year, 18 months. We've had it deployed in production now for about 6 or 7 months, and we're about 60 to 70% kind of towards in the process of migrating all of our operations into a Mesos cluster. So what is Mesos? The tagline for Mesosphere, which is the company kind of developing the open source project Mesos, is the operating system for your data center. The general goal is to allow you to treat an entire cluster or entire data center full of machines almost as a single machine. It's a lofty goal. They don't quite hit the mark, but it's a lot closer than anything else I've ever seen so far. So the primary goals of Mesos are resource sharing, so you can run multiple distributed systems and allow them to reside on the same physical hardware. Whereas before, if you wanted to run a Hadoop cluster, a group of Ruby on Rails servers, and an Elasticsearch system, all on the same set of hardware, that was kind of a systems administration nightmare. You'd have to make sure each machine had the right packages, say you want this running on these machines, this running on these machines, you'd end up maintaining multiple different images. Mesos will abstract a lot of that away from you and just let you get to the business of you want X number of services running, and this is the hardware you have available to do it. Resource limiting is another goal. So you might want to say, again, you want to run that Hadoop cluster, the Ruby on Rails system, and Elasticsearch, but you want to make sure that a Hadoop job never starves your Rails system of resources and stops your web server from responding. And that's another factor. You limit the resources any one process can actually take. Task isolation. So using either Docker or Linux containers, the Mesos will actually limit your process's ability to talk to each other, so you can kind of enforce those boundaries of communicating only via, network sockets or kind of defined channels of communication. It's not something you should rely on for security. It's not a system you'd want to say you're going to use it to run insecure code, but it's a good way to kind of enforce boundaries between software and limit, can't remember the word, but limit the crosstalk. Fault tolerant. So you can run Mesos with a single master, or you can do multiple masters, replicated, so that if one goes down, you don't lose the entire system. And obviously, the slaves can be hugely replicated, so that you can handle really, as many. You can set it up to allow for as many failures as you want. I think the most number of systems you can attach is 255 masters, and you need at least 3 to form a quorum. So that's pretty huge hardware losses and still maintaining a system. So you guys are interested in what you can do with this, I'm sure. But by itself, Mesos does not do much. It sits there and it says, hey, I've got a bunch of resources. Everything happens through frameworks. So a few kind of off-the-shelf frameworks that you can go download and play around with right now. The one a lot of people are using is called Marathon. It handles a long-running tasks. So with Marathon, it's easy to say, I have this web service. I want you to always keep 10 instances of this web service running. And it'll handle it for you. If one crashes on the machine or a machine dies, brings back up, pops up a new one, you never even notice it was gone. Kronos is like cron, but on your entire data center. Schedule a task and say, run this every hour, this every day, this every week, and it'll find the resources and run it. All the kind of traditional stuff, Hadoop, Spark, Storm, kind of the big data tools of the day can be deployed easily on a Spark cluster, or on a Mesos cluster. And then Jenkins, I think there was a talk here a couple weeks ago. There's a plugin that allows you to use Jenkins, Mesos, as your Jenkins build servers. Anytime there's a job to do, it'll bring up another build agent on your Mesos cluster, do your build, and then shut it down. What we've taken that to heart is we have a Jenkins server running standalone off on its own, but it's on an AWS micro instance with no hardware. It would take us 4 hours to do any significant build on it, but because all of our actual builds take place on big, beefy, instances in our cluster, they all happen really fast. And there's a ton more. All these are links. Like I said, if you're playing along, that's a link to the actual Mesos website where they have a list of all the kind of open source frameworks that are out there. Custom frameworks can do anything you want. I'm going to talk about one custom framework that we wrote, but in the end, frameworks, the amount of code in them is actually very small. Essentially, the only thing you have to implement is a piece of code that receives offers from the cluster and launches tasks. So the machine will say, hey, I have 5 CPUs and 20 gigs of RAM available on the machine with this host name. And your framework will say, okay, launch these 4 tasks on there. And that's basically the entirety of the framework. All the actual code is kind of in your logic of deciding what tasks you want to run where. So what is Mesos not good at? Kind of the limitations. The biggest one is tasks with persistent state. Mesos is a poor choice at the moment. They've promised that down the road they're going to introduce some better tools for dealing with this, but at the moment, I wouldn't recommend running a database or a stateful application of any kind on Mesos. Because like I said, the rug can get pulled out from your app at any time and brought up on totally different hardware, so you have no idea where your database files are going to be. And multi-data center replication is another feature they promised is coming down the line, but isn't there yet. So, that's not an issue for most of us, I don't think, because we don't have multiple data centers. But for some people, that is an issue. So, the kind of the meat tonight, I'm going to talk about how we use Mesos at Juristat. And they actually go down, not just left and right. So after, there you go. So I mentioned that we use Jenkins. We're also pretty heavily invested in Docker. So whenever push happens to our version control system, Jenkins is going to pick that up and do an automated build. That's pretty standard, I think. Run the test, generates a Docker image, tags a Docker image with the commit and build number. That makes it really easy for us to say, you literally want to deploy this version, this commit, of any application, and we can trivially deploy that on our system. We have a private registry, and then it deploys the image via Marathon, which I mentioned earlier is the framework for long-running applications. So go ahead and click down. That is the entire deploy script. So we, I don't know if any of you guys are familiar with JQ. It's like sed, but for JSON. Wonderfully useful tool. Downloads the configuration of the application, replaces in the configuration the existing Docker image with our new one we just built, stores it in a config file, and then pushes that config file to Marathon, and then Marathon deals with the rest. It's smart enough to handle rolling restarts, so if we push to our production environment and we have 10 instances up, it's going to restart them one at a time, zero downtime, and Shani can attest to that. When she pushes her project, about 20 minutes later, it's deployed. No one has to do anything, and the code for it, as you can see. I mean, I'm not joking. This is the entire deploy script.
So is it Marathon that's doing the rolling restart?
Yes. Yes. I think there's one more. Yep, that's it. So I mentioned Marathon. That's the thing we actually use. We use it for all of our long-running stateless services. We have different environments for development, staging, production for all of our products. And then we use it for all of our internal services as well. Oh, go back and go down. So there's a little bit of cruft cut out of this, but that's basically an entire definition of a Marathon application. It's a bit of JSON. You give it an ID. We do everything with Docker. You don't have to. It just makes it a lot easier. The Docker image, the ports you want to expose. I have some errant text in there for some reason. And then down here is the interesting thing. So you can say how many resources you want to give it. So this is one of our internal things. It's never going to have many users, so we give it a quarter of a CPU and 512 megs of RAM.
Is that then kind of reserved for that application?
Yes. Yes. And it'll never take more than that. Updating configuration.
What I mean is, will it take those resources away, even if it's idle?
Yes, they are reserved for that process. Nothing else can use them. Go back down. Yeah, I was done talking. Yep. Back down. So configuration can be updated the same way. You just take the same bit of JSON, update the bits. If you want to, say you wanted to scale it up from 10 to 20 instances, you would just take that JSON file. You don't have to include anything else except the element you want to update. Change that instances 10 to instances 20, and do a pull request to the URL of the application, and it's going to automatically scale it up for you. Updating happens, rolling restarts, zero downtime. It's just about as seamless as you can get. And crashed apps are automatically recovered. Okay. Bamboo is another piece of our stack. Bamboo is not strictly, it doesn't run on Mesos, but it's kind of a companion app to Marathon. What it does is automatically configure HA proxy based on your Marathon instances. So in our case, we have a bunch of applications that are deployed on there. We have different domain names to access different ones. We do all that configuration in Bamboo. And then anytime the Marathon configuration changes, an application crashes and gets brought up over here, Bamboo is going to update HA proxy on all the machines it's running on and restart it, and then it's more or less seamless. The actual experience of using it is that you never see anything go down. You know, I think if a machine went down literally in the middle of an HTTP request, you might get an error, but that's the only situation where there would be a problem. Kronos we use for pretty simply generating summary statistics. You know, we use it to store all of our, how many users are on the site, how about how many of this? And we store all that data for our dashboards and internal reporting. All of our kind of database compaction and cleaning and those sorts of things. And the other thing we do is use Kronos for one-off tasks. You can actually set up a task without a schedule, and then Kronos is going to sit there and never run it. But when you do want to run it, you get an easy web interface where even the least technical person on your team can log into it, search for the task they want to run, hit the play button, and it's going to kick it off and do it. This is our custom framework. It's called Mesos Task Queue because I am the least creative person on earth. It is a task queue. It's more of a meta queue. So the general idea is we have a lot of things we want to run. We have documents we want to OCR. There's websites we want to go scrape down. We want to take that scrape data and process it. We want to upload it into any number of databases. And all that stuff needs to happen, but some things are more important than others. So we created this. The general concept is it's an HTTP server, and any app can push a task onto the queue to get run. So we have a bunch of schedulers that say every week we want to go to the Patent and Trademark Office and scrape this web page. And so every week it's going to put a task on the queue to say go do that. But we also want to process any data we have before anything else. So the queue knows we have a JSON definition file that says how you want to process your queues, and it supports prioritization, round robin, a number of other constructs that allow you to create kind of fairly complex hierarchies of when you want to execute what tasks and in what situations. So if you want to get started with Mesos, there's a couple really easy ways. Mesosphere provides a thing they call Elastic Mesos, which will trivially deploy a Mesos cluster on AWS for you, send you the keys, and it's easy to get stuff running on there. They also have the same scripts for the Google Cloud Compute and DigitalOcean. Or if you want to, it's really easy to just download and run on your own machine. If you have an Ubuntu machine, add Mesosphere's repo and do apt-get install Mesos, and that's it. You're up and running. So I'm going to show off our stuff in a bit and show you guys. Do you have any questions before I do that?
Yeah, what's like the overhead, right? When I say spin up this task, how long does that take? You know, is it saying to run it for like a task every minute or something?
Sure. Yeah, so we had a bunch of lightweight tasks for OCRing documents, something like 5.5 million. And the actual, so to give you an idea, when we were running a manual system that we just had a daemon running on each system, trying to do our own inter-process communication, we were getting something like 85 to 90% CPU utilization on the instances we were using. When we switched over to Mesos and this custom task queue, we were easily clocking at 100. I mean, it just pegged all the time. The time to launch an application, once you tell Mesos to launch a task, the only kind of spin up time is for us pulling down the Docker image, and then it's pretty much launched. You can't just go to the machine and say launch this task though. It works by the Mesos is going to offer you resources and you have to accept them. So if there's no resources to offer, you can sit there forever and never be able to launch anything. They're working on some tools now that allow you to control the amount of resources that get offered to different things, but right now, you don't want to run frameworks that you don't trust on your cluster because it's easy for any one framework to starve all the others of resources. It just has to, launch echo or cat random to dev null on all the machines, and then you're hosed. You can't do anything.
So would it be fair to say that you guys are taking this approach predominantly because you're using Docker containers? Because it seems like a lot of these functionalities are replicating what's already in AWS. I mean, ASGs, ELB, SGT, all that stuff is there. I mean, what's the value that you guys see?
The value for us was really came with the task queue framework we built, because we wanted to be able to run a bunch of machines and then fill up all the excess capacity with actually doing our data processing. So we run, a handful of large instances to actually serve our products, but they sit at, 10% CPU utilization all the time, except when we get bursts of traffic and then they go up. With this now, they're all sitting at 100 all the time, because we get to fill them up with whatever random work we actually have to do.
And you also put those large instances in an ASG, and so you can actually scale those on demand too, as Mesos needs more resource. Do you have any sort of?
We haven't done that. We're working on scripting some spot instances for handling back, long, large amounts of work we want to do, but right now it's just manual.
You said like a test rack workflow. What are you doing for OCR?
Test rack. It's a simple Docker container that you pass in a path on S3 that you want OCR'd, and it takes it, OCRs it, appends .text to the file name, and re-uploads it. Just about the dumbest thing in the world, but it works well for us. Okay, cool. I'm gonna walk you guys through our actual system here. So this is our dev cluster that I use for kind of testing stuff and doing our development. So you can see this is the standard Mesos interface. You get a list of the currently running tasks. You get the tasks that actually ran. The amount of resources in your cluster, how much are used, how much are offered, the tasks you've run, just some general statistics. And then for debugging, you have a really nice feature. Click on this and actually get the standard error and standard out of any of the processes that are running. Getting kind of into the meat of stuff. This is Marathon. We have you can see the different tasks we have running there, the resources we have allocated to them. If we were deploying anything, you would see it over here, and it would say say what it was doing. So if we wanted to, we have our Kibana server here. If you guys know the Elasticsearch logstash Kibana stack, but we use that. So if we decide we're getting way too much traffic on there, we can do that. And in a few seconds, it's launching 5 more. So you were asking what the lag was. That's the lag to launch 5 new tasks. So that, I mean, this is really kind of the meat and potatoes of our kind of actual operations, our products. It is an interface that looks a lot like this. We don't actually interact with it that much through the actual web interface. It's there mainly for convenience. It is nice to be able to log in here, just see what's running, see if anything's trying to deploy. You know, as I've worked on developing our task queue system, I've accidentally starved this of resources. So one of the features I recently added is the task queue will go and look at all of the other frameworks we're running and see, are any of them trying to do anything? Is Marathon trying to deploy something? And if it will, it won't submit any new tasks until deployment's done. This is the Bamboo, which is our the HA proxy configuration. Not a whole lot to it. Again, you interact with it mainly through a REST interface. And then Chronos for the scheduled jobs. If you want to run something, it's easy enough to click on it and hit run. These are all the ones on this system are scheduled. Well, that's what I had. Just kind of an overview. I didn't want to get too in depth into anything, but
you mentioned something about the Docker stuff. Obviously, has port findings and things like that.
Yeah.
ACL through your Bamboo. But how do you do your instance networking, security, things like that? What's your
for us, it hasn't been too much of an issue since we only run stateless things on Mesos. All of our kind of databases and everything like that are kind of a parallel infrastructure. So it hasn't been an issue. One of the projects that's recently come out is called Mesos DNS, which actually provides a DNS server on all of your Mesos slaves that allows you to access any other task running on it programmatically. Similar to how Docker, if you're familiar, will set the container ID as the host name, so you can use that to access other containers. It's kind of the same idea.
How do you know if that be plans for NFV or OpenStack or anything like that also?
I don't. I'm sure they do. They're trying to get to the point where they can run pretty much anywhere. But as of right now, it's just the three major cloud platforms. Although, like I said, ours was deployed manually on Ubuntu, so it would not, and we have automated scripts for deploying new masters and new slaves, so it shouldn't be too hard to integrate it into.
There are VMware numbers.
Well, I was actually referring to OpenStack or NFV network function virtualization. So right, you've got all these different applications and stuff's flying about. Do you have state firewalls? Do you have intelligence? Do you have all these other things? Because if I'm a bad guy, you guys have this cool shit.
Yeah.
Oh, cool. Now I have all your cool shit because there's nothing in between. There's no layers.
The security is pretty lacking.
Yeah.
At the
I mean,
moment.
that's just at least the initial impression I got.
They do support authorization as far as running tasks on the system, but it's security was very obviously kind of an afterthought. So you want to make real sure that you don't leave any of those ports exposed.
Yeah, because the keys of the kingdom are essentially on those controls.
Yeah.
So what the communication mechanism do you use container to container?
Oh, the Mesos, the scheduler, the frameworks, and the master, it's all just protobus over TCP.
Okay, yeah.
And So that's how all the inter-process communication happens there. As far as our infrastructure, we do use some proto-buffs, but it's a lot of JSON.
I do zero and yeah.
We played around with that, but I don't remember why we didn't. With the actual task queue, we just went with an HTTP interface, and I think it was just because we were all really more familiar.
Yeah.
Zero queue would have been a lot more lightweight and a lot more efficient.
Sure, yeah. Faster.
Yeah.
To do. So, what's your reliability there? With the whole thing.
So, like I said, we're 100% in AWS. Our masters are located. We're in a single AWS region, so if there's a whole region outage, we're screwed. But we can handle any 2 availability zones going down.
But has it also helped you?
No, actually, we've been, I don't know if I'd say fortunate or, properly configured. Anytime stuff has gone down for us, it's been because of a mistake I made. Starving the system of resources or not giving it enough, things like that, not configuring it right.
I have a question. So you said everything that almost all your servers are in AWS.
Mm-hmm.
So basically AWS, you're paying for that processing power, whether it's at 10% or 90. So this is a way of getting as much of that processor as you can.
That's the big use case for us, since we have so much stuff we like to do. That back end kind of workload, it allows us to fill up all of our servers.
Yeah, so the task queue, why isn't it open source?
It will be.
Is that public?
Yeah, I'm getting it polished up right now. There's still some warts with it. Right now, there's no way to figure out if a task you added to the queue succeeded or failed. So it's just kind of fire and forget. And the assumption has been you're communicating out of band to figure out what happened. That's the biggest thing we want to add. And then we're working on putting a nice web interface to it and adding multi-master reliability. But once we get those things done, it'll get released.
What does the database, what does it use for the database?
It uses Zookeeper for all its state.
Okay.
There's no actual database attached to it, so when you try to add a queue task to run, if it can't launch the task almost immediately, it comes back to you and says, I'm sorry, I can't do that right now. And so it doesn't actually internally maintain a list of tasks that needs to run, so there's nothing to lose if it crashes. But it does use Zookeeper for configuration as far as the actual priority configuration and all that.
So that puts the onus on the requester to remember to request it again.
Yeah, it's a
So-
feature.
Sure, but then how do you solve that?
In most of the cases like our OCR queue, there's a big list in MySQL of all the documents we want to OCR,
So
and
you
then
just
it
go
just
back.
keeps adding one until it succeeds, and then deletes it and goes on to the next one.
Okay.
That was a decision to kind of kick the can down the road to the people pushing tasks onto it, or try to keep it, but we wanted to keep that task queue as simple as possible, and the complexity of kind of all the scheduling and prioritization was enough. We didn't want to put anything else in there. Okay. Well, thank you, guys. My partners will kill me if I don't say this, but Juristat's hiring. In the next couple months, we're looking to add 3 or 4 developers, a project manager, and a data scientist. So if anyone's looking or interested, come grab a card and let's talk.
Great, thank you. Thanks so much,
Yeah.
Bob. Feel free to stick around and talk. There's more beer in the refrigerator, obviously. Next month, we'll be talking about Cloud Foundry. So Dan Kennedy's coming back to give us kind of an overview of Cloud Foundry.
There'll
So
probably be some pivotal
I'm gonna guess
salesmen.
there might be, but it is
in the
open
audience.
source, so yeah. So, but yes, it'll be interesting. Platform as a service. So we haven't
What's
talked
Cloud
about
Foundry?
It is a platform as a service. I'm actually,
Think of it as OpenStack, but it does do more Swift stuff.
so, yep. Stay tuned. Awesome. Thank you.
Thank you.
Yeah, I think Dan is a cloud foundry right now.
I'm sorry?
Dan is a